Welcome back, and we are going to go through some more examples on how to graph sine and cosine via 5 points. So here we see the instructions. The only thing that I'm going to say that we don't necessarily need to do is find this vertical shift. We can, but it's not going to be super important right at this minute. So here we go. We have the function. It's a cosine function. So via the 5-point method, right, I begin by finding the horizontal placement. And so I take the input of cosine, so 5x minus pi over 2, right, and sandwich that between 2 pi and 0, and then solve for x. So add pi over 2 to all components. And so this becomes 5 pi over 2, and then divide all parts by 5. So I get, coming up here, pi over 10, and then less than or equal to x less than or equal to pi over 2. And then with that, increments, so I need to find the interval width, right? So effectively find the period. Okay, the period here, this I could imagine that is 5 pi over 10 for pi over 2, and then the pi over 10 would be just 5 or pi over 10, so then the difference would be 4 pi over 10 or 2 pi over 5. And then so for the increments, right, I would take 2 pi over 5, divide that into 4 pieces. This is 2 pi over 20, which is pi over 10. Okay, so I found the increments. So then if I'm thinking about making that table of values for that vertical part, right, I would start at pi over 10. Okay, again, this would also be the phase shift. Pi over 10, and then it would be 2 pi over 10, which would be pi over 5. And then 3 pi over 10. And then 4 pi over 10, which would be 2 pi over 5. And then the last one would be 5 pi over 10, or pi over 2. Okay, and then, so again, I initiate these y values according to the function that I'm working with. So cosine, right, they would start at maximum, center, minimum, center, maximum. Okay, and then the next column, right, I have to take that times a. So a is 3, so 3, 0, minus 3, 0, 3. Okay, and technically I'm done because there's no d, but normally I would do ay plus d, and so that is just the same as what I had in the previous column. So do it if you want, but you don't have to. Okay, so I have my points, right? Pi over 10, comma 3, and then so let's see, horizontally, I have no markings on my graph. So I'm just going to say this mark here, I'm going to call that pi over 10. So that's where I'm going to start, and then I'm going to increment, right, by pi over 10. So next spot would be 2 pi over 10, or pi over 5. And then another pi over 10, so 3 pi over 10, which would be just that. And then 4 pi over 10, which is 2 pi over 5. And then pi over 2 would be 5 pi over 3. Okie dokie. So now I have the right horizontal positioning, right? It would be just in here. And then vertically, right, I need to go up to positive 3. So 1, 2, 3. I'm just going to call that 3. And then down to minus 3. Okay. And now I'm ready to put things on my graph. So let's see. So pi over 10 gives me a 3, and then it's 0, and then minus 3, 0, and 3. Okay, and so here is my sketch of one period of this function. Okay, and so just to recap, making sure I answered all the instructions, identify the amplitude. Oh, I haven't done the amplitude. Amplitude is just the 3. Okay. Period, was 2 pi over 5. Phase shift was the pi over 10. Vertical shift here would technically be 0. My center line did not move at all. And then identify key points in one full period. So when it says identify points, sometimes if your sketch is not that great, I like to label it. So just pi over 10, comma 3 for each of the 5 points, just to add some clarity. But if it is very clear based on your sketch, no worries. Okay. And then we press on. All right. So for this next one, okay, same set of instructions. I want you to pause the video and resume the video when you're ready to see the solution. Here's my answer. So first of all, walking through this, I found the one cycle. Okay, took 2 pi x plus pi over 3, sandwiched it between 0 and 2 pi, solved, got x was between -1/6 and 5/6. Okay, great. And then from there, that told me that the phase shift was -1/6, right? And then period was just 1, so the width of that interval is 1. That allowed me to say the increments was 1 divided by 4, which is the same as 3/12. Okay, and that I wrote for a specific reason later on. So with the increments, right, known, then I can get my table of values. Here are my 5 key points, their initial y values, and then I went through and scaled them appropriately. Scaled and shifted. Okay, got the final points. Now, in setting up the graph, this one was a little weird to set up in that what I did is I let each tick mark on the graph represent width horizontally at least of 1/12. So -1/6 was -2/12, so that's why it's 2 to the left, and then I incremented thereon. I just labeled the x values of each key point just so I could use that as a quick reference. Vertically, I went up and down using increments of pi over 4, just because I had fourths here, and so I said 1 pi, 5, etc., etc. Okay, and from there, in that grid, I was able to plot the graph of the function. Okay, so a little bit more interesting one to set up, but still using the same steps as what we saw of finding that horizontal placement first, okay, and then finding period and phase shift along the way, finding the increments that we would use on our graph, and then with those x values of the key points known, find the y values using the multiply by a and add d approach. Okay, so we're all set to graph, sine, and cosine now and their transformations.